Theoretically, I'm streaming, maybe? Oh, mirrored things. It appears to be showing up on YouTube. Cool. All right, let me, let's see if any random YouTube people filter in here, in which case that would be super duper cool. But I am going to go check a Discord server that I've been playing with lately and see if anybody's interested. Of which, you know, maybe we'll get a person. I should probably copy a YouTube link, huh? Yeah. How do I share this? Help. I really don't know how to do this. Is it just... No. I don't want to be on YouTube Studio. This is embarrassing. Here we go. Oh, shoot, there is actually somebody watching. Sorry. Sorry. Part of the reason I'm doing this stream is because, you know, oh, shoot, obviously there is actually somebody watching. Sorry. I wouldn't say I'm not very good at it. Part of the reason I'm doing this stream is because, have a lot of history doing it. Oh, shoot, there is actually somebody watching. Sorry. I wouldn't say I'm not very good at it. Part of the reason I'm doing this stream is because, let's copy this. Oh, shoot, there is actually somebody watching. Sorry. I wouldn't say I'm not very good at it. Part of the reason I'm doing this stream is because, let's copy this. Oh, shoot, there is actually somebody watching. Sorry. I wouldn't say I'm not very good at it. Part of the reason I'm doing this stream is because, let's copy this. Oh, shoot, there is actually somebody watching. Sorry. I wouldn't say I'm not very good at it. Part of the reason I'm doing this stream is because, so. Oh, shoot, there is actually somebody watching. Sorry. I wouldn't say I'm not very good at it. Part of the reason I'm doing this stream is because, so. Oh, shoot, there is actually somebody watching. Sorry. I wouldn't say I'm not very good at it. Part of the reason I'm doing this stream is because, so. YouTube videos, oh, sorry. I wouldn't say I'm not very good at it. Part of the reason I'm functioning so. YouTube videos, oh, sorry. I wouldn't say I'm not very good at it. Part of the reason I'm functioning so. YouTube videos, oh, sorry. I wouldn't say I'm not very good at it. Part of the reason I'm functioning so. YouTube videos, oh, sorry. I wouldn't say I'm not very good at it. Part of the reason I'm functioning so. YouTube videos, oh, sorry. I wouldn't say I'm not very good at it. Part of the reason I'm functioning so. YouTube videos, oh, sorry. I wouldn't say I'm not very good at it. Part of the reason I'm functioning so. YouTube videos, oh, sorry. I wouldn't say I'm not very good at it. Part of the reason I'm functioning so. YouTube videos, oh, sorry. I wouldn't say I'm not very good at it. Part of the reason I'm functioning so. YouTube videos, oh, sorry. I wouldn't say I'm not very good at it. Part of the reason I'm functioning so. YouTube videos, oh, sorry. I wouldn't say I'm not very good at it. Part of the reason I'm functioning so. YouTube videos, oh, sorry. I wouldn't say I'm not very good at it. Part of the reason I'm functioning so. YouTube videos, oh, sorry. I wouldn't say I'm not very good at it. Part of the reason I'm functioning so. YouTube videos, oh, sorry. I wouldn't say I'm not very good at it. Part of the reason I'm functioning so. YouTube videos, oh, sorry. I wouldn't say I'm not very good at it. Part of the reason I'm functioning so. YouTube videos, oh, sorry. I wouldn't say I'm not very good at it. Part of the reason I'm functioning so. Myself going on YouTube, but I can't hear it because there are no speakers plugged into this computer. Thank you. Okay, hopefully that's better. Improved. Anyhow, so yeah, this is just garbage that I've been working on. Obviously, you have watched me before, so you know the antics that I get up to. Excellent. But, you know, for people who may come later and watch this recorded, and if you haven't watched my previous videos, I just like futzing around with stuff, electronics and computer-wise, because I don't know, I have a fetish for figuring out how, not for figuring out at this point, I know, but, you know, when I was a kid, I always wanted to know exactly how the heck a computer works, because it's just like this magic box with crap in it. And that's what led me to doing dumb stuff like this. This is, if anybody that I work with comes to watch this video, Merry Christmas. I'm working on a single board computer project to give to my work friends so that they can learn more computer stuff. So that's what I've been working on recently. But I think it was that kind of got me on this this quest to do something that I guess I just hadn't thought about. The fact that I used to think about this a lot, and like I just stopped at some point. But you know, if I'm just going to do random pointless things, this would be a good one. I want to, and it says in the description. So I got me a ton of old consoles, much like this Nintendo here. I love them. I'm a retro games boy. That's why I have all of them. But the other thing is, like, they're just computers, right? I mean, no shit. But especially older consoles like the 8 and 16-bit era, and a bit going into like the 32-bit era, like the difference back then between a console and a computer was so vast, but also like not. Because like look at the NES for starters. It is a 6502 based machine. It has some custom hardware in there, but at the root of it, this is just a 6502 computer, like an Apple II or a Commodore 64 or whatever. You know, it's just an 8-bit computer. It happens to be a kind of specialized one, but what I want to do, I'll see if I can find some old articles too, because I just kind of want to go over what inspired me to have this dumb idea ages and ages ago when I was a teenager and such. I always had this weird thing where I was like, what if you just strapped enough stuff to the side of a console so that it just became a regular computer again? Which, like, why would you do that? Because that's not the point of these. But I don't know. I like the idea of taking something and making it do something that it's not intended to in the first place. But that it's kind of funny because I almost feel like an 8-bit console is kind of making a personal computer CPU do what it wasn't supposed to do. Like, it wasn't made to be a games box, but Nintendo said, let's take this and turn it into a games box. So they did. So I want to unturn it from a game box. So I'll start with my thoughts on the NES, because my plan is, and this is why the video says Season 1, we'll see how far I get, you know I'm flaky, but I want to kind of start at the start and get more advanced as I go. I'm going to start with the NES because it's pretty much the oldest console I have. It's going to be relatively simple. You can only do so much with it because, it's a 1.7 megahertz 6502. So, you're going to be able to do 8-bit computer things with it. But, basically, I want to, for starters, well, you see, I had a video earlier on my channel. I made this thing ages ago, before I actually bought a Sega Genesis proper flash cart, which, of course, I don't use for, like, ROMs or anything, and I don't mean that as like a wink wink. I don't use it for ROMs. I just use it for programming because that's who I am. But anyway, so this is, if you go back and watch one of my very old videos, this is a flash-ish cart that I made for the Sega Genesis for fun because I was playing with Sega Genesis development at the time, and that was kind of attached to this whole idea because the Sega Genesis has the controller ports support being fairly slow but standards compliant RS-232 UARTs, and I thought, okay, what if I like leverage that to make development a little easier, or like port GDB to it and have it communicate over the serial port and whatnot. So I came up with this because the idea is it has some ROM on it and it has some RAM on it, and so the ROM is kind of like this bootstrappy thing that starts the thing up, and then it actually copies the ROM into RAM, and then does a write to somewhere in memory that this logic is sensitive to, that switches the mapping between the ROM and the RAM, so that now suddenly you're running out of RAM, and then it has kind of a serial monitor in it, so from another computer you can chuck data onto these chips from a host computer, and that way you can just slurp code onto this, run it, restart it, make changes, slurp it down onto here again. But that's very in the vein of PC-ish stuff, and I was thinking about that kind of thing at the time. So I kind of want to start with the same direction with this guy. I know I'm going to need to probably start by disabling the lockout chip, which, for the record, I don't know very much about the NES. I was not an NES kid, as mentioned in the Genesis cart video, because I grew up with a Genesis in the mid-90s. So, like hardware-wise and whatnot, I've never done that much looking up on the NES, because I only bought this a few years ago. So I would never had like a good reason to look up, you know, like how the PPU works and stuff like that, and what the memory map is like. But there are some vague things I know. So we're definitely going to need to, for starters, disable the lockout, which I think I just need to basically clip a pin, or I'd like to have this be mostly as reversible as possible. Like, I don't really want to make too many mods to the console itself. It's more that I want to make peripherals that enable PC-style I/O to this thing, and write software that lets me use it like a PC, you know, operating system type stuff. So we're going to need to start with disabling the lockout chip. Then I want to make a similar kind of cartridge, and I know NES cartridges are kind of weird because they contain the sprite memory as well, or the tile memory, which I don't really plan on doing too much sprite and tile based stuff. But if I want to do, you know, character output on the screen and do character tiles, then I'm probably going to need to know how to do that more properly. But the other thing is, I don't want to ruin an old NES cartridge, ideally, so I'll have to think about how I want to do that. But I'm thinking a similar thing where I'll make kind of a RAM flash cart for this thing. That'll work kind of like that, where it'll kind of act as a BIOS for the system that'll boot it up and do whatever I need to get, you know, whatever I do for an operating system or similar booted up on this thing, and also allow for rapidly changing the code. Or I might just be lazy and just put because the thing is, I don't think I have many ROM sockets around. I have a lot of. I finally got a sorting bin recently. I have a drawer full of random EEPROMs, but most of these are earmarked for, actually specifically this project, for making simple single-board computers for my coworkers. So I either would need to buy more EEPROMs or have it be in a socket so that I can pull them out and repurpose them. And ideally, it would be like in a ZIF socket, and I do have some ZIF sockets, but like dedicating a whole ZIF socket to this, I don't know. But maybe that's the way to go. Maybe that's the cleanest, easiest thing, is just make some kind of cartridge without ruining an original NES cartridge with a ZIF socket on it, and just yank it out and put it in my programmer and put it back and forth. That would be the easiest, but it's also the least sexy. But I have a problem with making my projects overambitious isn't even the word. Just like getting too big for my britches, and like I can execute the ideas, but they're gonna take way too long because, you know, I'm making it too baroque. So I'm gonna try not to do that. So maybe we'll start there. But we definitely need a cartridge that has a BIOS-y type thing going on there. Oh, that's right. I might not need it for swapping ROM and RAM like on that one, so that I can have like a programmable, like an on-the-fly programmable cartridge. But I do probably want some RAM on there because I have been reading up a little bit, okay? And the NES has 2K of onboard work RAM, which is, I mean, it's not the worst, but it's pretty low for trying to make this an 8-bit micro. And so I probably want to put some RAM on that cart as well. So maybe it won't be as complex as having that switching memory remapping logic, but I probably do want to strap some SRAM into this cart that I'm building so that we have a little more RAM to work with. So that's step one, I think. Step two is we need some input to this thing. Oh, let me make sure my OBS switching stuff is set up correctly here. Did it switch? Did it do the right thing? No. That's the one I want. Here we go. Good, that's muted. Let me see if I can look up... Family Basic? Maybe you know about this, maybe you don't. I really only, like, I think I knew this in the back of my head, but had kind of forgotten about it, and it wasn't until I was like searching to see. I kind of thought someone had put a BASIC on the NES before, like it makes sense. And yes, indeed, Nintendo made this thing called Family Basic for the Famicom, and there's a thing that will make things more complex for me that I can't just re-implement exactly what they're doing. But it was, it was basic. They sent you a keyboard. It's got this keyboard here and a cartridge with BASIC on it, and bingo bango, you had BASIC on your NES, and why not? It's an 8-bit micro. They all ran BASIC. That makes a lot of sense. You had a lot of other stuff like that on there, because I think, is it the ColecoVision also had like a keyboard add-on that you could add to it so that you could make it into a computer. So similar idea here. The thing that complicates this is that this keyboard, so I didn't really know this. I was just doing some research on the NES because I figured I should probably know something about the hardware. And there's a very good wiki that, of course, I did not bookmark. But let's see if we can find it. But basically, there is, on the bottom of the NES, yeah, and I guess it's even, I think it's under there, right, there's an expansion connector, but I don't want to, like, break this plastic off to use it, ideally. I don't know. We're going to have to figure that out. I might just have to connect stuff to the cartridge. Who knows? We'll see what we do. Because, again, I don't want to mod this thing too hard. I want to make this stuff that I can just, like, plug into it peripheral-wise, and, whoa, it's a computer all of a sudden. But anyway, so there is an expansion port that I don't know if I'm really going to be able to use. And then there's the cartridge ports, which seem like, if you're going to plug in peripherals to the thing, that seems like the thing. But one of the issues is, obviously, they're built for basic, being a controller. So it's your regular shift register. There's one line for data. There's one line for, whatchamacallit, for clocking the chip, for sampling the inputs on the controller side. And that's it. But the thing is, the Famicom, I don't even know where it's going to be in here, but let's just look it up on Wiki. So the Famicom, and I was vaguely, like, in my visual memory aware of this. So you can kind of see right here, there is a connector, and that is not, I was going to say it's not a controller connector, but it's kind of a controller connector. It's this 15-pin connector that has some of the controller pins attached to it, but it also has an extra, or a couple extra data pins exposed from the controller register, and that doesn't exist on the NES. So the thing is, that's what the keyboard plugged into, and that made life make a lot of sense because they basically made it so that, and this is what I was thinking of doing, and then I looked up how their keyboard worked, and I was like, that's great, but it uses that port, and I don't know how I could possibly do that with the normal North American Nintendo controller ports. Is they basically read, okay, the way that a normal Nintendo controller works, if you don't already know, and most of the controllers of that era, is that, like I said, there's a shift register chip in the controller, and all the buttons are connected to it, and it's an 8-bit shift register because most things were 8-bit widths in 7400 series logic. So it's a 7400 series shift register of some sort, and there's a pin on it that when you assert it, it samples all of the inputs, and then there is a clock input that as you clock it, there is a serial out pin, and it shifts out the data from each of those 8 inputs on the package. So you attach 8 buttons to it, and then what you do on the Nintendo side is you basically send that reset signal to, or not reset, the latch signal to grab all of the controller inputs, and then you clock it 8 times, read those in, and you know what your 8 button values were. And it's open-ended because really on the NES it just exposes an interface for setting or clearing the latching pin, and reading serially one at a time. Every time you read a register, you get the next bit out of the shift register over that data wire. So you read the register and it automatically clocks the data clock and reads the next value and shoves it into the register in the Nintendo, and then the CPU reads it and you get that value and you see, was it low, was it high, that button is on or off. But there's no reason, and this is the way that multi-tap adapters work, is like there's nothing that constrains you to only reading 8 bits. You could sit there and read, just ask it for bits all day. With the normal Nintendo controller, that just means that it's going to run out of data eventually and just start returning you all zeros or all ones, depending on how it's wired. I rent this and I forgot what it is on the Nintendo. Doesn't really matter. But so for a multi-tap, that makes sense, or that's a benefit, because you can just read the first 8 and then automatically have it, put a little bit of hardware in the multi-tap. I'm assuming this is how it works. I've never pulled apart a multi-tap, but and then the next 8 would switch to reading from the next controller, and so on and so forth. So, you can kind of share one data line between 4 controllers in that way. And then, similarly, like for controllers with extended buttons, which I don't know if that really happened on the NES so much, but it happened on a lot of like 8 and 16-bit controllers. Like a Genesis 3-button versus Genesis controllers are a little weirder, but a Genesis 3-button pad versus like a Genesis 6-button pad. More or less, you just clock in, you detect in some way or the other that it's a 6-button pad, and then you clock in however many extra bits, because your game is aware of a 6-button pad and it can read 6 more button reads out of the controller. So the keyboard works similarly, because again, this port that's there is, and I hope my face isn't covering that up, let's do this. This port that's there is actually kind of, it has, I think, clock and data from both of the controllers, or one of the controllers, or some mix thereof, plus some extra pins that are also attached to the same controller registers but aren't available on the NES. And so I had the same thought that they already implemented, except that they have a way of doing it, which is basically, what if we're going to talk about the way that input stuff works for various different things, let's talk about keyboard matrices 2, which I feel like a lot of people, especially people who are going to watch this channel, already know roughly what keyboard matrices are about, but let's actually see if Wiki has an article. Keyboard matrix wiki. Sure, of course it does. But I was also hoping they would have a nice little diagram, and they don't. Okay, well here's kind of if you haven't seen this before. So, I mean, the way keyboards work, I have no idea if you'll be able to see this, but there's a bajillion keys on here, right? Like, you don't want to just have each one, like, obviously, you don't just have a wire for each key that you're sending over, that's running through your USB cable or what have you. And even internally, like, you don't want a wire from each key going to the little microcontroller that's on your keyboard, because that would be a bajillion friggin' inputs. So what you can do is you do matrix multiplexing. So what you do is you put some keys all connected to one wire, in groups of however many, depending on how many keys you have and how you want to break it up. And then in the other direction, you have the other side of each switch connected to a separate wire. And you generally, like, you'll drive one of the, if you call this X wires and Y wires, if you drive voltage on one of the X wires and then read your Y wires, you can look at, okay, we know at this time X was on, and like if this key was pressed, then this would be a positive voltage and all of the other ones would be not asserted. So you'd know this is the key that's pressed because at this time the microcontroller had this line turned on, and when it read from these lines, it got a voltage here. And then, it would scan through this one, and then this one, and this one, and this one, and go back to the start. So, you know what makes a lot of sense is, firstly, why am I even talking about keyboard matrices? Because, like, couldn't you just use a PS2 keyboard and a microcontroller or something to make something? And sure, but I have this. This is a TI-99/4A keyboard, because I at one point had a TI-99/4A, and then I ripped it apart, and then I never put it back together because I'm a terrible person, and then I think I threw away a bunch of the parts. Anyway, I still have the keyboard, and I used it for a bunch of different stuff, so we're going to need to do some work on it and do a little bit of repair, but I want to use this for my keyboards for these projects, just because why not? And of course, like any other keyboard, it's already wired up in a matrix. Like, as you can see, these are this is the connection to whatever system, and so some of these are going to be pins for the X wires, the X lines, and some of these are going to be pins for the Y lines, and once I figure out what those are, then we can just, we could attach a microcontroller to it and read it in the way I just described, or we could make some simple dumb circuitry that allows us to, without a microcontroller or anything, just like scan the keyboard matrix via the NES cartridge port. That's my plan. So, what's a decent way to do that? How do you do that with just like the two inputs and two inputs? Two outputs. No. We have the clock, we have the latch, which is out from the Nintendo to the thing, two outputs, and an input, which is the data back from the controller. So, if you just wire up some logic so that if you shift in 8 bits from the controller port, then that's going to be like, if we have an 8 by something matrix, then we can clock in those first 8, or really it could be anything. We clock in the first however many inputs, and then when we're done clocking those, then the logic on the board automatically moves to asserting the next Y wire, and then we do the same thing, and we clock in the next 8. So it's really like having a really big controller, but it has this matrixing thing going on also, where we'll automatically flip through between each of the keyboard rows. So far, still so good. That would require a little logic. We'll need a shift register, or take a existing register chip, because I'm trying to use what I have here. I have so much dumb crap sitting around that, like, I don't want to make orders for new stuff. So I'm going to try and use what I have, and I don't have any of those straight up shift register chips, but I think I have octal D flip-flop situation that I can wire up to work that way, and that will handle the clocking in some data and then shifting it out. Maybe 2 chips I might need for latching the data into the shift register in the first place. And then we'll just need another, basically like a counter chip or something wired up to act kind of like a counter. Not a counter per se, but I'm sure there's a technical term for that, but one where it will assert each, it'll have N lines, and it'll assert each of those N lines in turn and then cycle over again. And so, all we need to do is count 8 clocks, and then we'll use the other chip to cycle to the next line, and then use the latch control to latch in this side of the matrix, and then clock in 8 or whatever things, probably 8 because that's the side of these chips, and then then after you do 8, then that circuitry will automatically again rotate to asserting the next line, and you keep doing that for however many lines you have. But here's the rub. How do we know which row the keyboard is currently on? Because we're not telling the keyboard assert this row, right? It's that the keyboard is going to be automatically rotating or iterating through asserting each row of the matrix, but we're not telling it which row to be on. So going back to the Famicom design, that's exactly what they do for the Family Basic keyboard, but it uses that 15-pin port, and the 15-pin port has an extra output on it that's just like for general purpose, which again, the Nintendo controller port does not have. It's not wired up in any way. And so what they do is they use that pin for telling the circuitry on the keyboard to basically reset itself and go back to row 1. So again, like I'm doing this stream just to like talk about what my plans are and think through some stuff, and so I don't know. These are just ideas, but that's the issue. Is I need some way of like we have everything else. We could build that circuitry. It would take a handful of chips. It'd be a fun little project in and of its own right. But how do we have the NES tell the keyboard reset back to row 1? Because we need an extra line for that. And the one thought I had is, and I'd have to think about working out the logic for this, but maybe it's like we have one fixed fake row that's always, or there's a couple thoughts. Maybe we, okay, let's say we have like the one side of the matrix be 7 lines or bits wide, and then the 8th one is always grounded for all rows except for like the first row. I'd have to think about how to build that logic. It shouldn't be too bad. Like I should be able to do that. And then maybe we have like an initialization routine that just scans the keys and has it keep scanning until it gets a row where that bit is on, and then it goes, oh, this is row 1. That's one thought. I think that's the way I'll go. So that's a lot of babbling about the keyboard, because the keyboard is kind of the second big project after we get a basic cartridge running here. Then what? Because there's so much we can do. You can strap literally endless things to the side of this. Let's go back to the overhead view, so as we can chat about some of the stuff that I have that I can strap onto the side of this, do dumb stuff with. Let's ignore this one for a minute. You may recognize that if you have watched me in the past, but we will get to it. It's going to be related. Okay, so yeah, I think I'll talk about this one first. So for my, again, if you watch the channel, you may recognize that's my 65816 breadboard computer that I've played with off and on. It's broken right now. I don't know exactly what's wrong. Some stuff came desoldered on the back, which is unsurprising because, yeah. But I should get this working again someday. I'm sure it's not too broken. Anyway, as you can see, it has an expansion slot on there, and I was playing with building expansion cards. I had this was a video card that was working kind of, and then I stopped working on it. And there you go. And then I stole parts from it, which is why it doesn't have a clock crystal, or this was a CPLD. It still has the RAM on there. Anyway, another card that I had started building was I bought a bunch of these, and this is, you probably can't see it because it's like hard to see with the naked eye anyway. I'm not even going to try. These are, let me read it off, N82077SL. It is the floppy controller chip, not from the original PC. It's a derivative of the one that was on the original PC. I think these were used in the PS2, like this actual chip. Not this chip came from a PS2, but like this was the specific controller chip that was used in the PS2 for floppy disk control. So anyway, I got a bunch of these because I wanted to attach floppies to my 65816 machine, and I never finished this, but I have all the parts, and I might even just like steal this board and make it super janky because I already wired up a bunch of the stuff to the floppy drive header, and I have the clock on here and everything. So I mean, why do more work than you have to, right? If you've already done it fast. But so that's the thing I'd like to do. Which then raises the question again of, do I just want to make a hyper cart that has accessories coming out of it, which I don't like, because like I want the cart just to be like a cart. You jam it in there, you close it up, it's a cart. It just does what a cart does. It accesses the BIOS for the machine, and does all your booting and stuff, and it's just for the software and maybe the RAM expansion. But again, we have an expansion port, but you have to like, I don't want to mess with that, man. Come on, I don't want to ruin this thing. Maybe I can just like run, like solder some ribbon cables directly to what's in there, or make a little thing that can plug into what I assume is the header in there, and then have it go to ribbon cables that run out the cartridge. Would probably be a good idea. Yeah, that's the way I'd prefer to do it, is use the expansion port for expansions, use the controller ports for controllers, peripherals, and then just have the software thing for software. Again, these are my rules. I know this may not make any sense. It's not about for ease of work. It's about like the aesthetic and the gestalt of the whole thing, right? Because I'm doing this because it's stupid, because it brings me joy. So yeah, maybe I'll do that. I lean in that direction. So anyway, once we figure out how to bust out the CPU bus from the expansion port in a way that's not too non-reversible and gross, get some glue logic going, stick this into it, and write code to read floppies so that we can, have our operating system be a disk operating system. Maybe even have it, because this is what makes a PC to me, which is funny because like 80s 8 and 16-bit computers they boot straight off the built-in ROM that generally has BASIC on it. If you've ever played with that kind of a vintage of computer, you might know that. If not, that's the case. Is like the Apple II, pretty much like most, because the original IBM PC even booted off of, like the BIOS booted to BASIC if you didn't have a disk inserted. But to me, having grown up in a slightly different era than that, something that makes a computer is like the BIOS has like a bit of initial program load code in it, right? That knows where the drives are, knows how to scan them to see if there's something bootable on them, and then pull some sectors into memory and start booting, right? Like that to me is a computer. So that's kind of, I think, where I'd like to get with this, is that the cartridge has kind of like an initial bootloader on it that will be able to scan the floppy drive, see if a disk is inserted, and then we can make our own floppies that operating system goes on. That feels computery to me. But either way, just being able to read and write floppies would be super fun. And then I think that's kind of the extent of it. There's also, so people who might be saying, I have no idea who is even watching at this point, but if you are thinking in your head Famicom Disk System, yes, but no. And to expand on that thought, Famicom Disk System floppies are a totally different kind of floppy. I don't even know if they're like the same sector size and sector count and stuff as any other kind of floppy. So I don't know. This is the thing that I've had in the back of my head. Very different. Like the layout of the floppy, probably crazy different. It's different hardware. It's probably rotating at a different speed, so there may be some assumptions on like disk access time to the games in there. I don't know. But stretch goal maybe is that while it's different and it's not like you could just strap a floppy, like a PC floppy drive to this floppy controller attached to the bus, and like it's a Nintendo floppy disk system now. Like that would not work at all. It would be pretty hilarious to, because like ostensibly you could take a Famicom disk system image, and especially if the sectors are like your normal 512 byte sectors that pretty much all floppies are, and you can just take the sector data and write it onto a floppy so that it's not going to be the same layout, but we don't care. We just want to know where the sectors are, and then have our own software in the cartridge that knows how to load that data onto the disk and start executing it, even if it's not in the same layout and stuff, and it doesn't work the same way as Famicom disk system hardware. It can still know how to read the sectors off the disk, implement whatever like BIOS, like EEPROM, like ROM routines that the floppy disk system, or that the software on the floppy disk games expect for, like, please read me a sector or whatever, which I don't even know if there are probably service routines for that, I would imagine. I would doubt that the games just like do really low level hardware access, but who knows. And so then like you could be playing Famicom disk system games off of something that is not even close to being a Famicom disk system, except that it's a floppy disk attached to a Nintendo. And that would probably be so much work, but it's also so fucking funny to me that it's really appealing. But that would be a ton of work, and I don't know, stretch goal. Maybe we'll think about it. So the last thing that I have to say about my plans for this specific project, what I'm calling Season 1 optimistically, is, let's get back to, did I get to the right window? Did I do it? Where's my OBS? This is the sign of good streamers. You guys know what's going on before I do. Yay! Okay, that seems right. Let's get to a web browser, huh? Let's go back to Family Basic. So bringing us back around, this is, to me, like I was saying at the top, this is, if I was going to make a computer out of it, it is contemporary with, the Apple, like the 8-bit micro scene, the Apple II and the Commodore 64 and the PET and all of those 6502 machines that it's really close to. The 6502 was crazy popular for home computers. And all of those, like I was mentioning a second ago, do it the old school 8-bit computer way where there's just BASIC on the onboard ROM, and when it starts up, it just starts executing the BASIC interpreter right out of ROM and it gives you a BASIC prompt. The fun thing is, I bet I can find this pretty quick. So someone might have like a ROM for the Family Basic cartridge out there. I mean, I'd almost guarantee it because, of course, everybody has everything. And it's not like this is particularly obscure. But that's not enough for me. That's I don't just want to steal that and just put it on there and then we're done. Maybe we could play with it as a starting point, but I don't know. What is out there is, some people may know, they released Microsoft at some point. Let's see. They released the Microsoft Basic source code a while back. Yeah, so somebody has it here on GitHub. So another history lesson, talking about the old 8-bit micros, they pretty much all ran Microsoft Basic. And there's this whole history there where, and I didn't appreciate this enough as a programmer, but it's kind of interesting regardless of what you think about Microsoft. Like, we think about Microsoft as like the Windows company, but to me, when you actually like really follow the history of Microsoft and stuff, they're a languages and compilers company, and they still are to this day. I mean, like, obviously .NET and .NET Core have become super huge. I mean, I'm biased because I do that for my daily work, but they've really blown up in the like cloud-based applications space. A lot of stuff runs ASP.NET, Web API stuff and whatnot in the cloud. So anyway, yeah, they're really like a languages company, and that's the place to be at because the operating system market is good because you want everybody running their software on your software, but languages and runtimes and compilers and everything are like such a level above that because you want what's better than having people's software run on your software is having the software that other people make created by your software. And then it's even beyond operating system. It's like if your language is popular and people use it, like that is a market. Anyway, I'm going and rambling into that history lesson, is that Microsoft, as probably most people know, I don't know, their first product was Microsoft Basic because there was the whole Altair thing. They weren't a company at all. They called up Altair, who was making this new computer. They said, Altair was saying, we need a BASIC interpreter for this machine so people can use it. And Bill Gates basically called them and said, yeah, we have an interpreter you can use, which they did not. And then they spent a ton of time cramming and wrote Microsoft Basic, which shipped on the Altair and was like basically the Altair killer product. And now that they had this code base for Basic, they just kept making Basic products. So since Altair had Basic and people were using it and it was so well known at the time, then I don't know the order, but then Commodore came to them and said, we need a Basic. And they said, all right, we'll take the Basic we wrote for that and we'll port it to 6502. And then now that they had a 6502 version, I don't remember if the original Basic that ran on the Apple II was the one written by Steve Wozniak or if it's the other way around. But it was either the first or the second version of Basic that ran on the Apple II was Microsoft Basic, because they were like, oh, you have a 6502 Basic? Let's throw it on there. And so on and so forth. So like, I believe C64 and Commodore PET and VIC-20 Basic is a derivative of Microsoft Basic. So the cool thing is, this is the 6502 source code for Microsoft Basic. So let's port Microsoft Basic to the Super Nintendo. I don't know if anyone's ever done that before, because the source code has been around for a while. And I was trying to remember, I keep coming back to Big Mess of Wires. If anybody knows him, he's an old school guy. He has been around doing silly projects like this for forever. But let me see if I can find Big Mess of Wires, Microsoft Basic. Yeah, I don't know what's on here, but Big Mess of Wires, one of his projects that he did is he basically did a discrete TTL rough implementation of the 6502. Like, it wasn't exact, but it was very close instruction set wise. So he took and this was back in 2008, like I said. He was doing this back in the day. And so he got the Microsoft Basic source code and futzed with it until it worked on his homebrew machine. And it's my understanding, I can't find the article anymore, but I swear ages ago I was reading an article where somebody else was porting Microsoft Basic to something else. And I mean, really, I just need to look at this source. It's right in there, and it looks pretty well documented. But that basically there's like, most of it is pretty self-contained, but then like there's a routine for like getting a character from the keyboard, and then there's a routine for writing a character to the screen. And so really all you have to do is like maybe set up where tell it where your memory areas that you want stuff to be stored at are, because everybody's computer memory map is slightly different, and then implement those two calls, and that should basically be it. I think there's also a call for like saving the program to tape drive, which I don't know if we'll implement that, or if we'll add commands for reading and writing stuff from the floppy to Microsoft Basic. Could be interesting. Maybe extend Microsoft Basic to be our disk operating system, because that's kind of how Apple DOS works for the Apple II. If you've never played with it, is you've got Basic on the Apple. If you put in an Apple DOS floppy, it basically patches the onboard Basic to give it some commands for reading and writing floppy disks. So all of a sudden now Basic is just also your DOS command prompt. So maybe that's a thought. But in general, I think it may be doable to take this source, compile it, make modifications to it, and see if we can't assemble it into something that will work on the NES. Like, we'll use the tiles, because that's exactly how like text-based graphics works on a text mode on a video card. A video card that actually has text mode, not like, a frame buffer, like a Linux frame buffer console. Like, actual text mode is, it's basically the same thing as tile graphics. It's the exact same thing, except probably, lower BPP than what this can do. And, otherwise it's pretty much exactly the same. You have a set of character tiles, or map tiles, or whatever, and they happen to be characters, and then you map that character on screen where you want to print that character, and now you have text mode. It's the same thing. It's the exact same thing. So we can use that for our text mode stuff, ostensibly. Oh, because that's another thing. One of my like stupid self rules for this is that we could also just like attach a serial port to this thing and like have a serial console to it, but I want actual output on the screen, and especially something like this where it's as simple as like I basically want it to be an 8-bit basic box. Like, having low resolution text graphics on a TV screen is exactly how that would work, and I'm sure that's exactly how Family Basic does it, I'm sure too. But so we have to just implement, ostensibly from what I understand from this code, we have to implement the code that sets up that screen, and then when Basic wants to write a character, it just hands us that character, and we have to implement the function that actually does that and puts it into the video memory. And then our routine for scanning the keyboard, once we've built it, is the other one that we need to implement for reading a character, so that when Basic is sitting there in the prompt, it's basically sitting there waiting for our keyboard routine to give it a character, and then when it does, it adds it to its internal buffer and prints it on the screen, and blah-de-blah. basically implementing those two things, which sounds super simple but will super not be, I think is all you really need to do to get Microsoft Basic running on an NES. So that's going to also be a project. I don't know in what order I'll do all those things. I'm going to definitely start with, obviously we need to do the cartridge first because we need some kind of bootable medium to even start working. And I do realize like I can buy, like they make flash cards for this, but that's beside the point. I hope everyone understands my feelings here, is that I want to build a dumbass thing that I can plug into this that like is garbage, like, you know, like the stuff I've already built, like this terrible cartridge, which is a Genesis cart that wasn't working. It was broken, and I pulled the chip out of it and slapped headers on it to attach it to this breadboard, and it works, but it's ugly and it's homemade, and I love it. And you know, all my other hand-wired bullshit here, that is what I would prefer to do. Might get PCBs made because that's so easy these days. Might like prototype and then make a nicer PCB to slide in there just because it's so easy these days. But I like the doing it all by hand. There's a certain gestalt to it. You know, I'm doing this for fun. I'm not doing it like for a reason. So I might as well just take my time and do it the way I want to do it. So cartridge first, and then once we have that basically working the way we want, then let's try and get this. Oh man, I'm still on the. Yeah, I'm still on the. Get this keyboard fixed. Maybe on this camera you can see it. You can see I use this as an input to like when I needed individual buttons for certain things, so I cut a bunch of the traces. So it needs to be fixed, and then we need to build hardware for automatically scanning the matrix and being able to read it over this synchronous serial situation here. So I think that'll be step 2. Then step 3 is figure out the expansion port thingy. Well, see, this is where it starts getting, I'm not sure. Is step 3 try and port BASIC? Because I think, you know, basically if we can get a cartridge that I can put software on here and maybe some extended RAM for the system, get an input device going, and have software that works on it that is like computer software, like BASIC, I would be happy with that. Like I could move on if at that point I've just spent ages on the project and I want to move on from it. So maybe from there will be like the stretch goals, adding the floppy to it, trying to like, because one cool idea is instead of putting Microsoft Basic on the cartridge directly, is put Microsoft Basic, like develop our, maybe not our own file system, maybe just use FAT or whatever, but put Microsoft Basic as a executable binary on the floppy, and then when this thing boots up, we could put the floppy in and it will boot Microsoft Basic if that's what we have on disk, or whatever other stupid BS we want to put on that disk, like the Joe's dumbass operating system, you know, whatever we want to make. So that's why I'm not sure the order. We'll just see how it goes, I think. But that's my plan. It's a handful of steps, and it's going to be real stupid. And also a lot of it is going to involve, you know, just like sitting here soldering stuff, which takes forever, and I'll have to see if I can make that entertaining. But this is why I'm switching to streaming, is because it's a little bit less pressure, you know? It's like if you want to tune in, feel free. I'm the kind of person who loves just sitting and watching people do that, especially like if it's background or I have a ton of time or something. Or like while I'm working, you know, just throw it on in the background, and then I'm working with someone. I like doing that. But yeah, I don't know. We'll just see how this goes. But I don't feel like making super polished videos anymore. I just want to get on here. That's all I really wanted to do, was just like do dumb shit. And if people want to watch, that's super cool. So that's plans for season 1. Nope, that's the wrong one. Yeah, let's just go with this one. So as an outro, because we talked about what I wanted to roughly get done. I kind of wanted to get my OBS set up working. That's also kind of the purpose of doing this one. And also just like to give a heads up, because I know some people are looking at my YouTube channel or subscribing and whatnot, and will be interested when I post new stuff, but like, I don't know, I guess I want to make like a hype video so that like people can be pre-prepared, and if they didn't tune into this one, I don't know when I'll do the next one, but at least, you know, people can watch and be like, oh, he's doing this weird project. I guess I want to watch that, and give them a reason to tune in or whatnot, I guess. But season 1, this is again getting too far ahead of myself. The last bit of storytelling I'd like to do on this one is kind of why I got into this stupid idea in the first place. Like I intimated at the start, and I would have hoped you picked up on. This is not like an idea I had the other day where I was like, oh, this seems really like a fun, stupid thing to do. Let's do that. Like, this harkens back to my childhood. Let's actually... There's another thing that, let me see if I can look it up. So I was a big Dreamcast fan, right? A lot of people were, that's a whole scene. People who had Dreamcasts and liked them, like, they're weird about it. And I'm kind of one of those people. I don't know even what I would Google for here, but maybe I can just... Oh, let's look up Dreamcast. And I don't know if this site is even up or... Well, Archive probably has it if nowhere else. Dreamcast ISA bus. Ooh, this could be interesting. That looks like an interesting picture. Yes, maybe? Basically, as I try and find this, like, there were, for some reason, a ton of people fucking with the Dreamcast in the day. I don't know why that was a particularly, like, why that was the target. But for some reason, especially in Japan, I don't know if this is the one or somebody's implementation of this, which, of course, apparently this is Foon. Ooh, maybe Foon knows some stuff about this that I should pick up on. Maybe there has been development since Foon cast his eyes upon it. Yes. Okay. And of course, I link to Foon, which links me back to... Yes, this is exactly the page I was looking for. So, there's this expansion port for... I mean, all the consoles have expansion ports. Let's just stop right there. That's one of the reasons that I always wanted to do this, is when I was, like, in my early teens and started realizing how electronics worked, and that, like, oh, if you just know what you're doing, you can just, like, attach shit to that and make it do stuff, and it's just a computer bus, just like any other kind of, like for cards that you would plug into your computer. It's the same thing. So what if you just make your own cards? Is part of the appeal to me, so there's that. But it was, in particular, this Dreamcast thing, because the expansion port on the Dreamcast is just basically the CPU bus, like, buffered, like most of these things are. Like, I'm sure the one on the bottom of the Nintendo is the same thing, where it's basically the 6502 bus on a header, and the Genesis has the same connector that was used for the Sega CD. Same thing, it's just the 6502 bus on a card edge connector. So you can just add hardware to these things. So I think this was the first one that I saw, is that this guy in Japan made some simple hardware that allowed him to talk to ISA devices over the Dreamcast's modem expansion port. And I actually even... Oh god, where would it be? Because I still have... I just rearranged this whole office down here. Give me a hot second. I probably won't be able to find it, but hold. Because this is verifiable history here. Where would it be? Going to be such a bummer. Like, I know I just moved this thing around. It's in some very obvious place. But, now the pressure is on, so I'm never going to be able to find it. And the annoying thing is I know exactly where it was before I reorganized everything. God damn. Well, maybe I'll try and find it next time whenever I stream again, so that I can prove to you I have because this is it's a custom connector for that expansion port, obviously, because this wasn't the 90s when everybody was just using card-gen connectors. They were more sophisticated, so it's kind of its own connector. So what people were doing and what they did for this was you'd take the Dreamcast modem and you desolder the modem connector, the expansion port connector from the modem, and then use that so that you could have a connector. You'd steal it from there. And I did that, and I don't even know how far I got with that. Like, I took a ribbon cable and I soldered it to the connections on my modem expansion connector, and then I have no idea what I did after that. But this would have been, like, I was probably 14 at the time, so who knows how far I would have gotten. But yeah, very inspirational to me, because there is also ports. So this one is for NetBSD. So all he had to do, and I've looked at NetBSD source too, and I've wanted to hack on NetBSD source, so this also appeals to me. There's a NetBSD port for the Dreamcast, and so all this guy had to do is make this custom hardware, write a ISA bus driver module for NetBSD, and now NetBSD can talk to any ISA hardware that you can plug into this ISA expansion thing, which also includes, as you can see here, hard drives, because ISA, or IDE, ATA, it's basically just ISA. It's just an ISA bus that goes directly to the drive, and then the electronics on the drive implement the actual interface. But it's basically just a differently shaped ISA bus plug. So this was the whole thing that kicked this dumb thing off for me. Was like, what if 14, 13-year-old me said, what if I could just take a Dreamcast and make it into a NetBSD workstation that just booted straight into NetBSD off of a hard drive? So I want to get there. The end goal of this is, in however many seasons, I want to make that dream come true. I want to have a Dreamcast that has hard drives and stuff connected to it that will boot straight up into NetBSD, and that's my dream. So we're going to try and get there. In the middle, there's some places I want to go. I'm going to start with a Nintendo. If we manage to get through that, or I implement enough and then get bored of it. I'm a Genesis kid. I've got that Genesis cartridge thingy already. I want to make, and the 68K is a pretty powerful processor. Also, BMAU, like I said, he keeps turning up when I'm doing this for some reason. But let's see, BMAU 68K. So he at one point, or maybe let's see, 68K archive. No, this is a page on the Vintage Computer Festival. Category 68K. Because this is category 68K, and that just happens to be under it. So if we look back a few articles, basically he decided he wanted to make his own 68K based single board computer, because why not? And the 68K is a really cool CPU. And so he did so, but the fun thing about what he did is he took an old UC Linux kernel, which was a project back in the 2.x kernel days to make a version of Linux that doesn't require an MMU, because Linux generally requires an MMU for securing processes against each other. But you don't strictly need that. It's just that Linux is designed for it. But technically, you can just make all of the programs exist in a flat memory space where hopefully they don't stomp on each other, but they can. And then you can run it on things that don't have an MMU, which is a lot of old stuff. And so, for example, like the 68K is an awesome CPU for this, because the original 68K has no MMU. Later 68Ks do, which is why you can have like Linux for later mid-90s 68K Max, or late 80s, early 90s, because they have the later CPUs have an MMU, but the original 68K has no MMU, but he used an old UC Linux build to get UC Linux running on this very simple breadboard. And what's occurring to me is that the Sega Genesis is also basically just a very simple 68K system. And God knows, this has probably been done before, but what if I took some learnings from this guy as well when we get to the Genesis part, and
port UC Linux to the Sega Genesis, and then have, you know, the Sega Genesis as a Unix workstation. That's where I want to get to too. What are my other dreams? Those are the big ones. The Dreamcast is the like end goal. That's the one where the dream started, or the stupid idea that came out of nowhere started. And then the NES is I have the very simple 8-bit one. Let's start there. The Genesis is I grew up with the Genesis and I realized I could do the same things and plus UC Linux thing. And then maybe somewhere in the back of my head, because after that point you just start getting into machines that are just straight up PCs. Like the Xbox, not very fun. It was fun at the time to hack an Xbox, but like it's just an x86 CPU desktop machine. So once you've hacked the BIOS, you can just run normal Linux on it. The end. Maybe we'll have an interstitial episode for me re-hacking my Xbox. It was cool at the time, but it doesn't really fit into the scheme of this. And so on and so forth. But maybe the N64 could also be a cool one. Because, you know, I don't think the N64 has an MMU attached to the CPU either. But, you know, that would be pretty funny. Is everything in there is more or less made by SGI, a Unix workstation company, so turning an N64 into a Unix workstation would be pretty fucking funny. I'm trying to think of what other consoles I have. I have a Sega Saturn. That could be just interesting for... I have, like, no games for it. The Sega Saturn is just, like... I don't know, I just thought it was such an interesting console. It's another one that I didn't have one when I was a kid, and then I bought one from a used game store when I was, like, in my early teens or something. Like, maybe 12, 13. And it was just because I thought it was interesting. And then I've only ever had like one game for it and I don't play it. But I still think it'd be really cool to learn all of the weird chips in there. But I don't know how interesting of a target that is for a PC conversion, or a workstation conversion. I love the PlayStation. I was didn't grow up with the PlayStation, but again, this is probably... Why does everything feel like it was like 12 or 13 or 14 or something? But me and my sister got a PlayStation because she dearly wanted to play DDR, and PlayStations were cheap at the time because it was the PS2's heyday. And so me and her went in on getting a PlayStation, and I was like a huge convert. I don't know, just something about the aesthetic of the PlayStation. I became a huge Resident Evil fan. And I also, if you look on my GitHub, if it's linked anywhere, I have a project where I'm taking the soft... Well, taking makes it sound like I'm actively doing it. It's something that I've hacked at in the past and really don't touch that often. But taking the soft GPU emulation from EPSXE, one of them, and basically writing C bindings for it so I can use it as a graphics API for doing video game stuff, just because I like the aesthetic. So I love the PlayStation aesthetic. Could also be interesting for a workstation conversion. It's another MIPS machine. That's very 90s Unix workstation. We'll see what I do. Those are the big three. That's what I'm going to leave it at. Is next time we're going to try and build a cartridge for this thing. We're going to start with the Nintendo. I really want to keep this going and see how long I can do it before I just get burnt out and or bored and or forget to do this. So that's me, y'all. Thanks for tuning in and listening to me ramble. I love rambling. I hope that there are people out there who enjoy just sitting around listening to me ramble for like a couple hours or whatever this was. Because I could just go on all day about like my dorky love for this kind of stuff and my love for doing pointless things that are totally silly, but also very technically... I don't want to pat myself on the back too much, but, you know, technically challenging. I don't know, just because that's my sense of humor. I think I've met some people out there who have a similar sense of humor, but it's kind of few and far between. I feel like there's a lot of people who either, like, if you are into this enough to have the tech know-how to do this kind of stuff, a good amount of people are just too busy wanting to use that knowledge to make new, fresh things, which totally fair, that, like, this kind of dumb shittery does not even register to them, because it's like, why are you wasting your time when you could be, like, making something relevant? But I have met some people out there who are messed up in the weird way that I am, and I love those people. Those are my people who, like, find humor in wasting your, like, God-given, hard-earned technical talents making useless bullshit that makes no sense. So I hope I can connect some people who are into that. But that has been my TED Talk for the day, and where I hope to go with this. And I'll see you guys later. Like I said, I don't have a super duper plan on when I'm going to do this again. I have some streaming gear coming in, because this is a shitty webcam. Well, it's not even that it's a shitty webcam, it's the one I use for work, and I want to just kind of keep this streaming set up so I can just come here and hit go. So I have another camera coming to like do pointing down at the desk stuff. And then we'll get started. So whenever that stuff comes in and I get it working, I'll see you there. Alrighty, love you guys. I'll see you around. I'll try and, I don't know, let me know if anybody like would actually see announcements on YouTube if I post them. Maybe I should, my Twitter is linked on my YouTube page. It's like tiny in the corner because I guess they don't want you going to their websites, but if like nobody follows me on Twitter, but if people followed me on Twitter, or if you were interested, I will make announcements there. I am hijacking Soding's Discord channel because that's Soding. If anybody watches Soding, they inspired me to do the streaming thing again because I just like watching him futz around, but with software. So I announced this there and then just started streaming on YouTube. So I'm not sure like how I'm going to do announcement stuff, but I think that's the biggest takeaway is maybe go follow me on Twitter. It's there. I don't really post a ton there. I retweet dumb liberal asshole things. If you're not into that's okay. Ignore. I have strong opinions, but I would also rather just like get along with you because I want to be friends. But otherwise, I don't post a lot of other stuff. So I'll try and just put video updates there. Hopefully some of you will. Okay. All right. That's it. Love you guys. See you later.